Okay, today's video is going to be sort of like a little quiz to see how well you're doing with our equations to graphs to tables, etc. So taking a look at this equation here, we have y is equal to 3x plus 4. We want to see if this graph is correct for this particular equation. So you're going to answer true or false that it is correct or incorrect. All right, let's see if you guys are right. What you're going to do, remember, one of the first ways we can do this is to say that y is equal to mx plus b. We can do this. And then remember, we're looking to line everything up so we can see what is our m and what is our b. So this is my m. My m, remember, is equal to my slope. That's the slope of the line. And remember that slope is equal to rise over run. So that's what we're going to look at for this part. In addition, we also have this right here, which is going to equal our b, and we have to remember what b stands for. Remember that b stands for the y-intercept, or y-int. So in this case, it's equal to 4, positive 4. And I should go back up here. Our rise over run is equal to 3. If we look at our slope is 3. Remember, to make any whole number into a fraction, it's the number on top of 1, right? So 3 over 1 is my 3. So my rise over run is 3 over 1. Okay, so with all this information, I can check if my graph is correct or not. The first thing I'm going to do is I'm going to use my y-intercept right here. I'm going to use this number and I'm going to plot that point. Remember, the y-intercept is where does my graph, the graph of my line, in this case the blue line that you see on the graph, where does it cross over the y-axis? Well, remember, this here is my y-axis, going straight up and down like this. So where does it cross over? It crosses over right here at this point, which is 4. And so that's good. So far, so good. So far, this graph looks like it does go for this equation. Now, I also want to do my rise over run. Well, this is a little tricky because my rise over run would literally mean that I'm going to go up 3 from this point right here, from my point on 4. I'm going to go up 3 and to the right 1 because I'm going to rise up and go to the right 1. Well, remember, that's the same as doing the exact opposite. So instead of going up 3 and right 1, I can go down 3 and left 1, and that's going to give me the same answer, or do the same thing. So if I go down 3 here, from this point, again, from this point right here, I'm going to go down 3. There's 1, there's 2, there's 3. And then I'm going to go over to the left 1. And so that does intersect right there. My line intersects on that cross of the graph. Let's see if it holds true again. Go down 3. There's 1, 2, 3, and go over 1. And look at that. It does. I'm thinking this is true, so let's just do it one more time, make sure for good measure. 1, 2, 3 down, and then 1 over. It's right there on that arrow. So yes, this graph does, or is the correct graph, excuse me, for this equation. Let's take a look at the next one. Here we have y is equal to 2x minus 3. Take a look at the graph and see if the graph is correct, true or false. All right, let's take a look and see. Oh, actually, I'm sorry. Let's go back to the other one first for a second. Okay, on this one, if we didn't want to do it with our slope formula, what we could do is we could just make a table of values. So let's do it that way too. I'm sorry, I forgot to do this part for those people who like to do this. All right, so I'm going to have an x and I'm going to have a y. Remember, input, output. And remember, we're going to pick nice, easy numbers to work with. So I'm going to pick a -1. Always start with a negative number. I'm going to pick 0 because we want a 0 in there to help us out. And then I'm going to pick another positive number or a positive number. And I'm just going to do a 4th number for good measure. Remember, 3 points are all you really need, but I'd like you to do 4 just to make sure you're doing it right. All right, let's put our rule in here. So for our x value, we're taking 3 times x, and we're going to add 4 to it. And that's going to give us our y value. So now I'm just going to go ahead and plug it in here. So I have 3 times negative 1 plus 4. Well, 3 times negative 1 is negative 3. Negative 3 plus 4 is 1. Now we have 0. This is easy. This is one of the reasons why I picked 0. We have 3 times 0. Well, 3 times 0 is 0. Plus 4 gives me 4. Now we have 3 times 1. Again, another reason why I pick nice, easy numbers. 3 times 1 is easy to do. 3 times 1 is 3. Plus 4 gives me 7. And then 2, oh, excuse me, I'm sorry. 3 times 2, the 2 goes inside, so 2 is my x, plus 4. That gives me 3 times 2 is 6. 6 plus 4 is 10. Okay, so now I have my x and y values. So I'm going to double check them. Negative 1, 1. So going back to my graph, if I start at the origin, which is right here in the center, and if I go negative 1 to the left, and I go positive 1 up, look at that, I'm right on my dot there, so that looks good. 0, 4, I'm going to stay right here in the origin. I'm not going anywhere. And I'm going up 4 because I can't go right or left because my first number is 0, so I'm not going right or left. So I'm going up 4. 1, 2, 3, 4. Right there. Perfect. Now I actually won't be able to graph these next ones because it would be 1 and then 7 and I'm off my grid because here's 5 right there. And then let's say 6 and 7 would be about there. But we can see if we did that, that arrow is kind of continuing up there. So we're doing okay. And so we're pretty good. I think this is correct. And actually we do know it's correct. Okay, so let's go back to this one, like I said. We already answered if it was going to be true or false, so let's see what happens. Again, if we do y equals mx plus b, well, this time we have a little bit of a difference here. Our slope, our m, is 2, so m is equal to 2, which remember rise over run is 2 over 1, okay? But then we have our b. Our b is actually equal to negative 3. So our b is where our y-intercept is, and the y-intercept is equal to negative 3. That means on this y-axis right here, my blue line that I graphed has to cross over at negative 3. Well, this is not crossing over at negative 3. This is crossing over at what point? If you said it's crossing over at positive 1, you're correct. It's crossing over right here. There's my y-axis. My y-intercept is right there. That's a positive 1. Negative 3 would be somewhere. Well, not somewhere. It would be right here. That's the negative 3. So it's not crossing through there. It is a positive slope, though, so we're okay with that, but the rest of it's incorrect. Now let's look and see if it also matches with our slope. So just from here, if I was going up 2, I would go up 2, and then, actually, this is already 2. Because this is going, but no, that's going by 1. I'm sorry. Okay, this is 1. Okay, so we're going up 2, 1, 2, and we're going over 1. Should be right here. So my line's actually going to be a little off here. So up 2 and over 1. My line should be more like this if I was going from that point, but it's kind of wrong altogether, isn't it? All right, so that's not correct. So this one was false. Again, you could put in your table if you wanted to get your values for x and y, and then graph them and see if that works. Okay, here we go. Determine which graph matches the given equation. Same kind of thing, but this time you're given 3 different graphs. So which graph do you think it is? Is it A? Is it B? Or is it C? All right, let's look and see which one it is. Again, if we use our formula, y equals mx plus b, we have our equation as y is equal to 3x, but I don't have anything here. So obviously that means that we're adding 0 to this. All right, so when I look at this, here's my slope. My slope is 3, and my y-intercept is 0. So my my graph should go right through the origin. It should go right through the center because that's where the only place where 0 is. So the only graph that does that is this one right here, because right there in the center is where my y-intercept is. And again, we can double check the rest of this by our slope. M was 3. That's our slope. Remember that we're going to say 3 over 1. So let's see if that rise over run works. From the center here, I'm going to go up 3, 1, 2, 3, and over 1. And yes, that point is right there. Remember, I can do the exact opposite to go down with my other one. So I'm going to go down 3 and left 1. And again, that works too. So I've got the same pattern happening there as well. So that one is definitely the correct answer. Again, if I wanted to, I could make a table of values. So let's do that, in case you like to do that instead. So we have our x and we have our y. Remember, we're picking our nice easy numbers, -1, 0, 1, 2. And we have 3x is what we're doing there. So 3 times -1 is -3. 3 times 0 is 0. 3 times 1 is 3. And 3 times 2 is 6. Let's make sure these ordered pairs are on that line. We have -1 for x, and we have -3 for y. Starting in the center to graph it, -1 to the left and -3 down. It's right there. I should do another color so you can see that. -1 to the left and -3 down gives me that right there, which is perfect. 0, we already said, is right smack dab in the center, and our line goes through that, so that's perfect. We have 1 and 3. That means I'm going from the center over 1 to the right and up 3. And again, perfect. And 2 and 6, we're actually going to be off our grid, but let's make sure. 2 to the right and 6 up. This is 5 up right there. If I go one more, it looks like that arrow would hit that dot. So it looks like we're doing really well. All right, next one. Again, is it A, B, C, or D? Okay, let's take a look. We know that my slope is negative. This is a -6, so it's a negative slope. That means A is out. Remember, when we're talking about positive and negative slope, you want to think about walking. If this is a little person here, right? We're thinking about walking along the x-axis, and then when I hit the line that I graphed, am I going up or am I going down? In this case, I'd have to climb up, so that would be a positive slope there. If I was my little person here, walking along the x-axis, going towards my graph that I graphed, when I hit the graph, I'm going down. Since I'm going down, that's a negative slope. C is also a negative slope. So I'm going to erase this part just so we can see this in a moment. We can tell A is out, so that we know that one's gone. All right, so we know that B or C are both negative. Now we're also looking, though, for that y-intercept. Here's my y-intercept. Remember, y equals mx plus b. So 4 is my y-intercept. Which one of the graphs has an y-intercept at 4? It's going to be this one right here. There's what intercepts at 4. This one on the right, see, where does that intercept? This one here does intercept at 3. So this one is out as well. Now looking at this, let's make sure with our -6, from this point, this time instead of, we say rise over run, but because it's negative, we're actually going to fall. So instead of rising, we're going to fall because it's negative and then run. So we're going down 6 from this point right here. 1, 2, 3, 4, 5, 6, and then to the right 1. And look at that, we're right on the line. So it's perfect. It looks like everything else would be perfect with what we're doing. Again, if you wanted to, make a table. So do this real quick. We have x and y. So we have, and our rule was -6x plus 4. Again, nice easy numbers, -1, 0, 1, 2. So -6, oops, excuse me. Let's do that again. -6 times -1 plus 4. Okay, we got to remember our integer rules. A negative times a negative is a positive. 1 times 6 is 6. And then 6 plus 4 gives me 10. Then we have 0. Negative 6 times 0 plus 4. Well, this gives me 0. We like that. So then it's 0, 4. 1. So a negative 6 times 1 plus 4. That's a negative, pardon me, a negative 6 plus 4 gives me a negative 2. Remember, think money when you're talking about your adding of fractions, or excuse me, your adding of integers. We have negative 6 times 2 plus 4. This gives me negative 12. Negative 12 plus 4 is negative 8. And so when we graph that, we have this, that's our same thing here. Okay? Here's another one. Again, which answer would it be? A, B, or C? Okay, let's look at which one it's not. We know from our slope here, remember slope is the coefficient of x, that's the m, y equals mx plus b. So 3 is my slope. It's a positive slope. It's a positive slope, which means it has to either be which ones? If you said it's A and C, you are correct. B is a negative slope, so that does not work. Okay, now my y-intercept. What is my y-intercept? If you said positive 3, you are correct, which makes it right here on graph C. So this one is my correct answer right here. Because this one here is at negative 3, so this one is out. This is wrong. So my correct answer here is C. One more here. Let's do a couple of things first. Well, yeah, first of all, let's say which graph is it? A, B, C. Okay. Let's see what it would be. First of all, what is my slope? If you said 1, you are correct, because in front of x, remember there's always a 1, because if I just have x, I have one of them, so that's a 1x. So my slope is 1. What is my y-intercept? Oops. If you said negative 3, then you are correct. That makes this one out because the y-intercept is at 0. This one is at negative 3. I like that. This one is out because it's a negative slope. So that means that B is my correct answer here. Okay, so this is, again, just one way that we can go about going from our equation to a graph, or checking if the graph is correct by using our y equals mx plus b formula. Remember, if you do not like to do it that way, you can always use your table, and with your x and y's, just draw it out with your x and your y, and then remember to put your rule here in the middle, whatever the rule is. Like in this one here, it was x minus 3. And then remember for your x values, negative 1, 0, 1, and 2. Now again, those x values are for when you have whole number coefficients. If you have a fraction coefficient, remember you want to use a fraction-friendly number for x. So if you had 1/2, for example, you're going to use multiples of 2. If you had 1/3, you would use multiples of 3. If you had 1/5, you would use multiples of 5. Something that's going to make it easy to do that fraction portion of your rule. All right, I hope you did pretty well on this. This will be a good indicator to see how you might do on an upcoming quiz. So keep that in mind. If you're having any trouble, make sure you're asking questions next class. I hope you have a great evening.